Okay, students, let's go into the third video dealing with integers. What's the reason why the concept of integers was developed, and what's the key point about integers? What's the property which defines this set of numbers? The set of integers, interestingly, denote the first set of numbers where we are really going into an abstract concept. So that's the beginning and a very defining point. So what is the meaning of the first set of numbers where you deal with an abstract concept? And to know that, we have to continue with our discussion which we had in the first two videos. The first video where we discussed about the characters, the key properties of the natural counting numbers, and the second video where we discussed about the whole numbers, why whole numbers are called or denoted whole. So as far as the integers are concerned, that's the first set of numbers where we solve a particular problem by developing basically an abstract concept, an abstract property, and that's what we'll be looking at here. So continuing with the similar discussion we had in the previous video, you have got two boxes we denoted by the number 2. We are taking that on box out. Now the point is that how will you represent it? That is obviously 2 minus 1, that would be 1. So you have one box left, that is a single box. Note that we are defining very distinct objects, and if we remove that box too, if that single box is also removed, that obviously means that we have 0 boxes, which means that we don't have any box left. So no box left means 0 box. So 0 represent, as we have discussed in quite a detailed manner in the previous video, 0 represents emptiness, or it basically means that a distinct object or a distinct operation is absent. Now what about taking 3 boxes out of 2 boxes? Naturally and obviously this is practically impossible, but it can be expressed in mathematics. So if we can extend the number line to something like negative numbers, so practically impossible, because naturally 2 minus 3, that is minus 1, is such a box. You can't call a box as minus 1 box, because such a thing is simply impossible. But in mathematics, in a mathematical operation, extending the number line to the negative side, we can have minus 1. So 2 minus 3 minus 1 basically means that we are extending the number line which started with 0, 1, 2, 3 to the other side. So that's the key meaning. So integers represent the case where we are introducing the concept of negative numbers. And note that by introducing the concept of negative numbers, we are extending the number line to the left side, towards the other side. Other side means that the side which had ended with 0. So which obviously means that the set of whole numbers W starts with 0 all the way up to infinity. So 0 is the starting point for set of whole numbers, and for Z, that capital Z, which denotes the set of integers, there's no actually a starting point or an ending point, in the sense that it extends to infinity on both the directions. The only thing is that one direction is left direction is negative, the right direction is positive, but we have a midpoint that is 0, and numbers extend from this midpoint to both directions, to both infinities, that is negative infinity as well as positive infinity. And an interesting question would be, what is this? Is it capital Z denotes Zahlen, which is a German word which stands for numbers, and it's just not it is just not simply some kind of a random choice, because not that as far as integers are concerned, which are numbers which include negative numbers, that is numbers, so negative numbers, positive numbers, as well as zero. You can easily see that none of these numbers have any decimal part or a fraction, and also none of the numbers have fractions. So they are something like whole numbers. They are something like a number without a tail, a number without something extending. So in that aspect, naming the set of integers as, denoting Z as for the set of integers is quite right. So a nice definition as integers are numbers which are written without a decimal part or a fractional part. So that's a key point. So that's how we come to the next set after the set of whole numbers. First starting with the set of natural numbers, then whole numbers, and the third set is obviously the set of integers. So that's about integers and the obvious choice of Z as the symbol denoting the set of integers. Now going on to the properties of integers, and as I already mentioned in the previous video, students are requested to view the first video where we have a detailed discussion about the properties, and to get a better idea of what they stand for, what are their theoretical aspects. So the properties of integers, we begin with the closure property. The second property is associative property. The third property is commutative property. And the fourth property is the property of distributive property. So as I already mentioned, to get a better idea of these properties, students are requested to view the first video where we have a detailed discussion along with the examples. So the fourth one is distributive property, the fifth one is identity property. So that's about integers, why Z has been chosen to denote the integers, and also the importance of this set of numbers. So thanks for watching this video, and hope you liked this video. Thanks.